So let's recap chapter 9. We covered a lot of material. We have lots of formulas, but really they just kind of divide into two different areas, arithmetic and geometric. So I don't know if you want to stop and pause the video, copy all of this down, or listen to me talk and then copy. Whatever you do, just make sure that you get the notes written down as a nice recap of everything we've talked about in chapter 9. So sequences is what we began with. Remember that a sequence is just a string of numbers that are all connected in some way. So if we have an arithmetic sequence like 1, 3, 5, 7, 9, so on and so forth, we have a common difference of 2. We're adding 2 to get to each term in the sequence. We can write an explicit formula or a recursive formula. Remember that a recursive formula relies on the previous term. So we use the subscript a sub n is equal to a sub n minus 1 plus d, where a sub n minus 1 is that previous term. So again, a sub n relies on the previous term, a sub n minus 1, and we just add a common difference. Now, we also could talk about a geometric sequence. In a geometric sequence, we have a common ratio. To find the common ratio, you take the second term divided by the first, the third term divided by the second, the fourth term divided by the third, and so on and so forth. You should get the common ratio, which is just a multiplier, or maybe you're dividing by a number, in which case you would be multiplying by a fraction. So we can write an explicit formula or a recursive formula. Notice that in the recursive formula, again, we're relying on that previous term, a sub n minus 1. Sub meaning subscript. We also talked about series. An arithmetic series is a sum of the terms in an arithmetic sequence, whereas a geometric series is the sum of the terms in a geometric sequence. So series means sum, and we use the Greek symbol sigma to write a series, which is a sum of numbers. Our sigma has two indexes, our lower index and our upper index. Our lower index is usually 1. This is the first term in the sequence, and then we're going to add a certain number of terms in the sequence, and that certain number goes at the top of sigma. Next to sigma, you would write the formula, either maybe the arithmetic formula or the geometric formula for the sequence of numbers that you are adding together. All right, let's practice some examples. And I think I have, let's see, turning the page, I have 3 examples total. So, examples. Here is example 1. I would like us to find the missing terms. Find the missing terms, and then I'm going to tell you that this is an arithmetic sequence. I'm going to abbreviate sequence with SEQ, and our missing terms are after -13 and before -3. Now this is a sequence that goes on forever. It's not a series because I'm not adding these together. So I start and ask myself, what do I know for sure? I know that a sub 1 is -13, and let's see, 1, 2, 3, 4, 5. A sub 5 is -3, n is equal to 5. I don't know what the common ratio, or no, not common ratio, I don't know what the common difference is. This is an arithmetic sequence. So what I really need to know is what's the difference between one term to the next. Well, using this -3 over here as a sub 5, I know that it was found by taking the first term, a sub 1, and then adding n minus 1 times d. So my n in this case is 5, but what I don't know is that common difference. And then replace a sub 5 with -3. Let's do a little algebra. I'm going to begin by adding 13 to both sides, and I have 10 is equal to 4 times d. You know, 5 minus 1 is 4. I divide both sides by 4. 10 divided by 4 is 2.5. So my common difference is 2.5. That means to get from one term to the next in an arithmetic sequence, I add 2.5. So next in line after the -13 would be -10.5. Add 2.5, and that's going to take me to -8. Add 2.5, and that takes me to -5.5, and then -3 was given. But for sure, -5.5 plus 2.5 takes me to -3. So indeed, I found the missing terms of my sequence because it all lines up nicely. Let's take a look at another example. Example 2. In this example, let's find the number of terms in the arithmetic sequence and then evaluate a sum. So I'm going to tell you that we have from 2 to 10, and what's going on is we're taking half of n each time and then adding 3. So what we're going to do, I'm going to give you some jobs here. We're going to find the number of terms. What is the number of terms in this series? Let's do that. Let's find the first term. Let's find the last term. And then let's evaluate the sum. All right, well, how many numbers are in this series? Well, I can just look at this and say that there's going to be 9 terms in this series. In fact, I'm going to use a different color because I really want this to stand out. Okay, so I know there are 9. And you're probably thinking, wait a minute, we're going from 2 to 10. From 2 to 10, isn't that only 8 spots? Well, this is what's tricky about arithmetic, or summation notation. I mean, you're going to have the second term, you're going to have the third term, the fourth, the fifth, the sixth, the seventh, the eighth, the ninth, and the 10th. How many numbers is that? 1, 2, 3, 4, 5, 6, 7, 8, 9. It is technically 9 terms because you have from 2 to 10 is 8, but then don't forget to add in that first term. So there are technically 9 numbers in this series from 2 to 10. Kind of a tricky thing. All right, next up, let's find the first term. So to find the first term in this series, technically what I need to do is, actually I want that a little lighter. Okay, what I need to do is I need to find a sub 2 because I start here at 2, not 1 like normal. So to find a sub 2, the first term, I'm going to go 1/2 times 2 plus 3, which would really just be 1 plus 3 or 4. And then similarly, I can find the last term by evaluating a sub 10. A sub 10 will be my last term. This is going to be the last term. A sub 10 is 1/2 times 10 plus 3. Half of 10 is 5. 5 plus 3 is 8. So my last term is 8. And then what would the sum be? Well, I can do this on my calculator, or I could do it by hand. I think I'm going to go ahead and just use my calculator. In fact, I don't have my calculator on right now. I'm going to let you do that. So why don't you figure that out using your calculator, and we'll check our work, or we'll check our answers against one another tomorrow. Okay, so then let's take a look at one last example. If you want to pause the video and do that calculation, go for it. And then here's our last example. And so in this last example, number 3, we're going to evaluate the finite series for 8 terms. And I'm going to give you the beginning of the finite series. 80 minus 40 plus 20. And then I don't know what's going to happen. You know, something's going to be subtracted probably next. And then I don't know what's going to happen. And this will give me the 8th term. I don't know what the 8th term in the sequence is. Remember, series just means sum them all together. Okay, well, this is what kind of a series is it? Is it arithmetic or geometric? So my first question, the first thing I'm thinking about is this arithmetic or geometric? Well, how will I know if it's arithmetic or geometric? I'll know if there's a common difference or a common ratio. Well, how do I get from 80 to 40? I either subtract 40 or I take half. How do I get from 40 to 20? Negative 40 to 20. Well, I subtract 20 or I take half. And so it's looking like my common ratio is going to be -1/2. Check this out, 20 divided by -40, also -1/2. So indeed, I do have this common ratio of -1/2. So it is a geometric series. This is a geometric series. My common ratio is -1/2. Therefore, I'm looking at a geometric series. And then I flip back in my notes, and I know that if I want to find the sum of 8 terms in a geometric series, I need to know the first term, and then I'll multiply that by 1 minus r to the nth over 1 minus r. Well, I know s sub 8 will be equal to 80, my first term, 1 minus -1/2 to the 8th power, all over 1 minus -1/2. All right, this is a calculator punch. I've got my calculator up. I'm going to type in 80 times the quantity 1 minus, I'm going to put -1/2 in parentheses, -0.5, raise that to the 8th, and then close that set of parentheses. I'm going to hit enter. And then I'll divide that by the quantity 1 minus -0.5. I should have probably put that -0.5 in parentheses. That's a good habit to be in. Close that bottom half, and then I'll get 53.125. So my sum will be 53.125, or 53 1/8. That's the decimal approximation of 1/8, 0.125. Okay, so there we go. If we wanted to, we could have just written out 8 terms and then added them together by hand, but that would be tedious and not super exciting and really prone to errors. So it's best to use a calculator when you can. All right, that's it for that. Hopefully you've got a good handle on Chapter 9 and you're ready for the test coming up soon.